Hey guys, and welcome to the next video in our algebra series. This one is the finding the equation of a line lesson. So we have been starting to deal with, or we have started dealing with some different things to do with straight lines. We looked at graphing them in the last video in the series, and now we're going to look at the equation of a line. Once we have the equation of a line, we can do a whole bunch of different things with them. Okay, there is a few things to be aware of though when finding the equation of a line. So for example, horizontal lines. Horizontal lines have the equation of y equals b. Now this is because it only has a y-intercept. It doesn't have a slope because it is horizontal. It is a zero gradient line. It doesn't have a slope, therefore it doesn't have that mx part. It is just y equals b because it won't matter what x equals. Okay, and b is our y-intercept. Okay, so that's the first thing to remember. Okay. Next thing is our vertical lines, our straight up and down lines. For this one, we have an equation that is x equals k. So we use k instead of b because b is specifically for the y-intercept. Alright, but this time we're using y equals k, and this time k is the x-intercept, in other words, where it crosses that x-axis, and we have the same issue that we don't have a gradient because it is undefined. We have the undefined gradient, so we don't have an m in there anywhere. Now when we are looking at the equation of a line, the most common one that you're going to come across is the y equals mx plus b. Y equals mx plus b. So each of these parts of the equation actually do serve a purpose. So our m is the gradient. The plus b is the y-intercept. And then the x and the y well, these are our coordinates. So whatever you put in for x, when you work out the gradient and the y-intercept, you can get your coordinates. Okay, to find the equation of a line, you can do one of two things. You can substitute. Alright, you can substitute a point. Alright, a point in to find b. Alright, for y equals mx plus b. Or you can use a different equation altogether. So let me just move this up. You can actually use a different equation. So the next equation is y minus y1, y minus y1 equals m outside of x minus x1. Alright, so this is where we're just using a point and the gradient. Okay, so we have a point and we have the gradient, so it is point gradient form. Okay, now we are using our gradient for m that we have seen before. Okay, and those points of x, y, and x1 and y2, or sorry, I'll get that right in a second. So x1, y1, and x2, y2 are all on the line. Okay, so those 3 points have to be on the line for this all to work. Okay, now when we talk about collinear, all we're saying is we are referring, so the word collinear refers to points on the same line. So when I say that those 3 points from my equation dot point at the top, we have the xy, x1, y1, x2, y2. When I say those are collinear, I mean they are on the same line. Okay, they are cooperating almost on the line. Collinear, cooperating on the line. Collinear. Okay, that's the theory bits behind it introduced to you. Let's have a quick look at how it works in some examples. So here's our first example. We've got a pair of points, -3, 8, and 5, -2, and we need to know the gradient of that those points, of the line that those points are on. Okay, so very, very quickly we could do it one of 2 ways. We're going to show you both ways today. First of all, I'm just going to show you the algebraic way. So first thing I need to do is I need to determine which of those points is going to be the first point and which is going to be the second point. Easiest way to do it, 1 and 2. I'm going to set up my algebra. And there we have it. So I've got my formula there ready to go. Now I need -2 -8. All right, and then I'm going to have -5, minus -3. Now, -2 -8, well, that's pretty easy. That's going to be -10. 5 minus -3, well, that's going to be a little bit different because minus is going to be plus. So 5 minus -3 is really 5 plus 3, which is 8. And we can simplify our fraction down to -5/4. Okay, so that's what that one looks like. Let's have a quick look and see how it's going to work on the graph. So let's put in some points. All right, that's probably all we need there. When you're putting in your points on your graphs, you don't need to go super overboard. Just put in the ones that you need. All right, so my first point there is -3, 8, so I come across to -3, and I'm going to go up to 8. So there's my first point. Okay, so that's -3 and 8. My next point is 5 minus 2, so I come across to 5 and down to 2. So that's our 5 and -2. And between those two dots, I can draw in a line. Remembering to go through the line. So there's my line. And you can see here, if I was to come down this way, that my rise is 10 and my run is 8, and it's a negative gradient. Okay, that's a negative gradient, so it's going to be the negative like we said before. And we can see our rise is 10. And our run is 8. So that works out really nicely for us. Okay, let's look at the next. That's all we have to do for that one. Let's look at the next one. Find the equation of the straight line shown. So we can go through and we can do the exact same thing as we did before and put in this triangle. But that's completely unnecessary now that we have that formula to do all that for us. Okay, we can just whack in the formula. But we need the gradient, and then we can pop in the equation. So I can actually point out one thing first. Y-intercept. That's already part of our equation right there. I might just do that circle a little bit better so that you can see what the actual number is. I'm going to do my gradients. Okay, now my points. This is going to be 0.1. That's going to be 0.2, which is important for knowing where different things are going to go, because you don't want the number from 0.1 to go where the number from 0.2 is supposed to go. So we're going to have 13 minus 1 over 4 minus nothing. Alright, so that's going to make that quite easy. So we have 13 minus 1, which is 12, over 4, because 4 minus 0 is 4. 12 divided by 4 is 3. So there's our gradient. So now our equation in the form of y equals mx plus b, well, the plus b part, that's really easy to do. That's plus 1. We already saw that before. Okay, my gradient part, well, that's 3. And y and the x will represent any point on that line. There's our equation. I actually think that is quite straightforward. But let's have a look at another one that might be a little bit trickier because we don't actually have the y-intercept shown on our graph. Here we go. Let's find the equation of this line. Now we don't actually have a y-intercept shown. So I'm going to pop this here. Question mark. I don't actually know where the y-intercept is. It's not shown on my graph. The only thing I've got is my 2 points. So I'm going to have 0.1 and 0.2. Let's find the gradient first. Now I always do start with my formulas. It just makes life for me easier. It does help to figure out if you have made an error, where those errors lie if you've started here first. So hopefully you're seeing where those numbers are coming from. So 7 minus 11, 6 minus 3. So 7 minus 11, which makes sense because it is a negative gradient, is going to be minus 4 over 3. So we have minus 4 over 3. We just put it nice and clear, minus 4 over 3. That's our gradient. Okay. So if we are going to write our equation out, we have some of our equation already written. So y equals something x, all right, and then something at the end. Now, we know what the bit before the x comes into, so the and part is minus 4 over 3. That's what we just worked out. Now that we have that part of the equation, we still need to find that plus b section. So we can do some substitution and figure out plus b. So we can start with what we've got. And that's where we can start. So we can actually choose one of those 2 points to go in for y and x, work it all out, solve the equation, figure out b. So let's just use the first one. Just to get things going. Okay, so now we're going to have minus 4 over 3 which is minus 4 plus b. Okay, we're going to do our opposite operations, so it's going to add 4 to both sides. And that's going to get me b, and then 11 plus 4 is 15. So 11 plus 4 is 15. That is our plus b part for our equation. Now, if you really wanted to, you could double check that using the other point just to make sure. Now, there is one last thing that I want to show you, and that is using the point gradient form that we saw before. So that's this formula. So it is the y minus y1 equals x That's this formula that I have just popped on the screen. Highlight it nice and clear for you. So now we can actually use one of those points. Alright, I'm going to use the same point as before and the gradient that we've already worked out to get this going. Alright, so that first point, that's going to be 11. I'm going to have my minus 4 on 3. Alright, and then this is going to be minus 3 here. And then I do exactly the same thing as I did before. Okay, so I'm going to expand my brackets. Alright, so minus 4 over 3x. And we said before that minus 4 over 3 times 3 was 4. Well, it was minus 4, but we're now timesing it by minus 3, so we get that positive answer. And now we can start using some of our opposite operations, so we can add 11 to both sides. Leaves me with y minus 4 over 3x plus 15. So exactly the same answer as before. As always, these examples have come out of a Cambridge textbook. Hopefully this video has been a bit helpful. Good luck with your questions.